Hello everyone. From this video tutorial, I'm gonna discuss about demultiplexers. So, what is a demultiplexer? Demultiplexer is it's kind of a circuit actually, which use one input. Demultiplexer is a circuit which use one input and it multiplex demultiplex the outputs. So what we discussed in the multiplexers was there were several inputs. Several inputs is converted, actually transferred to a one bit. In multiplexers, the several inputs were there. The several inputs were actually switched between the selector and it's transferred to a one data outline. So in demultiplexers, what we are doing is the data outline which I told you, there's the one which we get from the multiplexer. The output from a multiplexer can be connected to here, right? The data which comes as a one bit is separated and shows the output. So this is done by the demultiplexing process. So demultiplexer is used to connect a single source to multiple destination, right? Think you have a one bit, so that one bit can be transferred to one disk and to another disk, multiple destination. The main applications area of demultiplexer is in communication system, right? In communication system we use like this is there's a similar kind of scenario using you have seen switches and hubs. So in hubs, two-way hubs are there, three-way hubs are there, like that. It's kind of a scenario which use demultiplexers. Splitters are there. So in telephone cables we have one telephone cable and then there's a splitter. From splitter we have two outputs. Similarly, the same scenario is applicable in here. One bit is coming, it is separated, right? So here's the truth table and the logic gate. So we will be discussing what will happen when the select is off and the input to 0, data input. When the select is off, initially I am going to discuss these two rows. When the selector is off, if you input 0, you will get this result. When the selector is off, if you input 1, you will get this result. Similarly, when the selector is on, active high, if you input 0, you will get this value. When the selector is high, if you input 1 as the data input, you will get 1 and 0 as the output. Let me start the simulation process using Logison. So initially I need two AND gates for this process. So I'll be taking two AND gates from here. I'll be reducing the number of inputs to 2. And then I'll copy paste this one. Then I need to connect these things with wires. Then I will be taking this data bit. Data bit should be fed to both AND gates. Therefore, I connect this one together. These two lines I will be connecting together, right? This is my data bit, feeding of data bit to the AND gates. So I'll be taking this one input. This is my data bit. Data bit is fed to these two gates and the switch need to be applied in here. So switch comes from here, and the off stage of switch is represented from here. This is my switch. I'll take a switch from here. I'll place it here. I'll make the direction as north. I'll fix it here. I'll add some display pins here. Another display pin. Right now my circuit is almost completed. I need to name my outputs and inputs. So this is my selection switch. Selector switch. This is my data switch. Data, it can be either 1 or 0. This is my output 1. This is my output 2. So this is the simulation of the logic gate which comes as a for the demux 1:2 demux, right? Multiplexer, demultiplexer. D means demultiplexing the input data. So it is 1:2. 1:2 means we are inputting one data, and that data is output as 2 units. We'll get as 2. Fetching is 1, what we receive is 2. Therefore 1:2. So we will gonna perform some data. What we're gonna do is we're gonna keep this switch as low, active low, and we're gonna send and see the data. We are gonna make on this switch, again off this switch. Then we'll be observing the result. Again, after that, as the second stage, we are going to switch on this one, and we'll be switch on and off this data switch. Then we'll be observing the data. Let me go through the truth table. So you can see my truth table from here. So when the selector switch is off, I'm initially going to discuss these 3 rows. These 2 rows actually. First row and this row. First row and the second row. So initially the switch is off at both stages. Okay. Let me start simulation. The switch is off. When the switch is off, data bit is 0. Data bit is 0. When the data bit is 0, output are 0 0. Output are 0 0. It's satisfied. Okay. Now let me go to the second row. Selector switch is 0. It's okay. When the data bit change from 0 to 1, the output will be 0 1. The output will be 0 1. Correct. Let me go to the next stage. I'm going to discuss this stage now. These last 2 rows. When the switch 1 and switch these 2 stages, when the switch is on. So I'm going to switch on this stage. Now the switch is on. When the switch is on, input is 0. When the switch is on, data input is 0. Output will be 0 0. It is confirmed. When the selector is 1, okay, I'm going to send data now. I'm going to send it. I start sending. Then the output will be 1 and 0. 1 and 0. You can see 1 and 0. So this is how one data is converted, multiplexed to 2 bits, right? So let me start my tutorial. After that we have 1:4 demultiplexer, right? So initially we have one input. The one input is demultiplexed into 4 outputs. It is controlled by this S0 and S1 switch. Think if the data bit is 1, data bit 1 comes here when the both switches are 0, 0, 0, 0, right? It indicates Y0 value. The switch comes to here. Then this one will be 1, other things will be 0, 0, 0. Right? Let me go to the second example. When the switch is data bit is 1, active high. When the data bit is active high, S1 is 0. This bit is 0. This is 1. S0 is 1. S0 is 1. This is activating now. So this one goes to here. S0 goes to 1. Similarly, while switching on and changing the switch S0 and S1, it will transfer to these upper 4 numbers, 3 numbers like that. So for the 1:4 demux, the logic circuit comes as like this. We have AND gates here, right? 4 AND gates. Every AND gate is connected to data bit. There's a one input here. You can see one input. We have only one input, and we have 4 outputs. This one input should be fed to each and every AND gate. So here we have connected to here. This same data bit we have connected to here. Same data bit connected to here. Same data bit connected to here. Then after, the switching purposes should be applied to each data. These are switches. A and B are the switches. So let me move on to my logicem environment. So this is my logicem environment. So I'm gonna start my 1/4 logic circuit. So what I need is 4 AND gates, which comprises 3 inputs. Right? I need 3 inputs. Number of inputs should be 3. And I'm going to copy paste. Okay. Now I told you the data bit comes here, and the data bit should be connected to each and every AND gate. Now this is my data bit. Data bit should be fetched to every AND gate, and I'll be indicating some switches here. From that switches, this gate will be sometimes this gate will be activated, sometimes this gate will be activated, sometimes this. It is controlled by the switches, right? So this input data is controlled by that switch, whether splitting it to 4 outputs. So I will make this input here, and I'm gonna take wire. And I'm gonna mark the first switch, and complement of that switch. I need to mark the complement of that switch. I need a NOT gate for that, and I will be changing side as south. I fix it here. And I make a gap, and from here I will make it like this. Okay, now this is completed. So this is my switch. First switch. Right, this is my first switch. First switch I'm gonna name as S1. This switch is S1. I need a similar thing like this, right? I need a similar thing, so I will be copy pasting this one. Another switch from here. Right, so from this switch I'm gonna take the main output. From that one also I need to take the complement of that switch to represent the off stage of that switch. I'm copy pasting this one. Okay, so now I have to connect these wires, these two switches. This switch is S2, right? Now I need to connect these wires. So initially I will show the combination comes as like this. One from this one come to this complement of S2, and the other bit comes to complement of S1. This gate is completed. Now this gate, one bit, right? One bit should represent the complement and the other should represent the original value, right? So this bit comes to original value of S2 and the other one is complement of S1. This is also complete. Now let me move on to this one. Data bit is okay. I need to connect this one for this one and this one for the complement of S2. And the last part, I need to connect this one to this one without complements to the original values. So let me trim. I'm trimming my circuit. Now I'm going to mark the outputs. I need display pins. I need 4 display pins. Now almost my circuit is completed. So what I want to show you is I want to start simulation this circuit. So let me show you my Word, right? This is my Word document. When the inputs, I'll be adjusting the frames, right? Okay, now you can see. So I'm gonna perform this simulation now. So this is the data bit column. This is the selector column. These are the outputs, right? When the data bit is 1, every time the data bit is 1, there will be outputs. When the data bit is 0, right? We don't need to talk about the selector. Data bit 0 means nothing is coming inside. Definitely the output will be 0, right? So I will be switching on the data bit every time. So where is my data bit? This is my data bit. I'll name this one as data bit. So every time my data bit is on, when the data bit is on, right, in the first stage I'm gonna start when S1 is 0, S0 is 0, S1 is 0, S0 is 0, S1 is 0, S0 is 0. My outputs are 1 0 0 0, 1 0 0 0. Correct. I have to label these things. This is Y0, this is Y1, this is Y2, this is Y3. Right. So let me tell you again. Data bit should be on. What is our purpose is to send this data bit and take output. So in order to send data bit, there should be a bit. It should be active high. When this is active high, switches is the main part who is doing the role. When both switches are off, it sends a signal that it is multiplexers as 1 0 0 0. Let me go to the second one. When the inputs are 0 and 1, here 0 and 1. When the switches is 0 and 1, it represents 0 1 0 0, 0 1 0 0. Outputs are correct. Let me go for the next stage. When S1 is 1, when the selector is 1 and 0, when the selector is 1 and 0, right, from the selectors it switched. So we will have the output as 0 0 1 0, 0 0 1 0. Okay, satisfied. When the data bit is 1, it almost 1. When the both switches are on, when the both switches are on, it should be 0 0 0 1, 0 0 0 1. So it's correct actually. Now everything is satisfied. So let me show you this step also. When there is no data, right, there is no data, we cannot talk about even the selectors, because there will be, even if we mark this as 1 or not, it will be 0. See, because there is no data bit is feeding inside to this circuit. So this is the simulation process of 1 to 2 demux and 1 to 4 demux. Right, one input is multiplexers, demultiplex as 4 outputs. Therefore, we call as 1:4 demux. Here we had one data input. That data input is output as 2. So we demultiplexed the one data as 2 outputs. So we call as 1:2. Similarly, we can take 1:8 demux. Like that, we can take demuxes from that. So hope you understand this tutorial. So thank you everyone.